Hello, everyone. Good afternoon, good morning, or good evening, wherever you are. Thank you for joining us on today's session. This will be a live coding session for the winter 2023 cohort, brought to you by Hamaye. My name is Julo Christian. I'm the Assistant Programs Coordinator at Hamaye, also a data scientist. Thank you, everyone, for joining me on today's session. This will be our first for the winter cohort, and subsequently, we'll have different coding sessions for different tracks. That's the data science track, data storytelling, DevOps, and data engineering. So for this stage A, the 4 tracks are doing the same course. So this will be the coding session for all 4 course tracks. All right, thank you once again for joining me. Today we'll be explaining some concepts in the stage A course, which is Introduction to Python for Machine Learning. So we're dealing on some concepts like NumPy and Pandas. So without wasting much of our time, I'll just dive straight into what we have today, and I'll share my screen. Well, I believe everyone can see my screen. Okay, I'll just drop it in the chat. All right. Like I said, we'll be dealing on the introduction to NumPy and Pandas, which is what we're doing in stage A. So just like the bedrock of machine learning. To begin, I'll be explaining concepts in NumPy and Pandas. NumPy, as we know, it stands for numerical Python. It's the backbone of all kinds of scientific and numerical computing with Python. NumPy is a library for the Python programming language. It offers comprehensive mathematical functions, random number generations, Fourier transforms, and more. So since machine learning is all about turning data into numbers and then figuring out the patterns, NumPy often comes into play. Then for Pandas, Pandas is an open source library which helps you analyze and manipulate data. It's fast, powerful, it's flexible. It is built on top of Python programming language. One of the main uses you can come across with is using Pandas to transform your data in a way which makes it usable with machine learning algorithms. So NumPy and Pandas are 2 important Python libraries for machine learning. So moving straight into the code. First off, you import your NumPy as a library using the code to import NumPy as NP. This is the generic way of importing it. You can also use import NumPy as anything you want. I can use import NumPy as DS or DB or my name. So as your choice goes, but this is the generic way of loading this, import NumPy as NP. So moving on, and basically I've already written down the codes to save time, so I'll be explaining as I move on to it. So the first one we'll be looking on is NumPy. So NumPy's main data type is ND array. By now, I think we already know different data types in Python, like the floats, the integer, the int32, Boolean, and also for NumPy, the main data type is the ND array, and ND array is the collection of the data type objects. So we have the 1-dimensional array, 2-dimensional array, 3-dimensional array, and just run this code so you understand basically. This is just like the bedrock of NumPy, and I'll be dealing on the statistics part. So just try and follow along, you understand it. So the best way to understand NumPy is like when you have the grand knowledge of it, it grasps it well. Then moving on, to check the shape, there's a code for it, a1.shape, the dimension, the data type, the size, and all. So if you run it, you see it. This shape here for this A1 is 3 by 1. Then the dimension is 1. The data type is int64. Then the size, C3 size. I'll show you a pictorial view so you understand better. I'm just run three of the codes, A2, A3. So to describe the anatomy of a NumPy array, yeah, this is just like a quick pictorial view for you to get a wonderful understanding of it. So for my A1, you can see this data, it's an array of 1, 2, 3. It's a vector, also it's a one-dimensional array. The shape is 1 by 3. It's just like matrix. If you have a good understanding of mathematics, matrix and vectors. Then my A2 will have a also more than one dimension array. So it's like a 2 by 3 matrix shape on per array. If you don't understand the meaning of arrays, you can just go on Google and type it. You understand what I'm saying by arrays and not. Then for my A3, we have a 3-dimensional array, which is 2 by 3 by 3. So these two as x0, as x1, and as x2. This is a 2. For me, a 1, 2 by 3, which is this axis 1, vertical, by 3, which is axis 2. This is the horizontal. So this is just like an anatomy of a NumPy array, 1-dimensional, 2-dimensional, 3-dimensional. So let me just go further, you understand better. So let me just create a simple array. This code, creating a simple array. There are different, like in your material, there are different codes in generating NumPy array. To get a NumPy arrays of ones, there's np.ones. This will give you a shape of 4 by 2. And also to create a NumPy array of zeros, the code use np.zeros. Remember, we loaded NumPy as np, so you can call it by np to give you a 5 by 3 by 3 array. This is 5 by this 3 by 3 array. Then I want to create another random NumPy array. This is a 5 by 3 array. And I'm using a code np.random.round8. This would generate an array of numbers from 0 to 10, with 10 excluded. And also, if you notice, if I run this code again, it will give me different arrays. That's a different number. If I run it again, it will give me a different answer. So basically, to stop that, you can use what we call random.seed to set the seed to ensure that, okay, if you run this particular code, you get the same repeatable answer. So what np.random.seed does, it ensures there's still randomness. It just makes the randomness repeatable. The same random numbers will be generated. So hence the pseudo random numbers. So if I run this now, since I already have a random seed, if I run the code again, it will give me the same answers as before. And also, I want to create another, the same NumPy arrays, but putting it in a data frame. That's what we'll use pd.data frame to generate it. Just put it like in a data frame. So, but here I imported pandas, import pandas as pd. I'll get into pandas shortly after this NumPy, so you understand everything. So, viewing arrays and matrices. So arrays are like matrices. Let me just run my previous arrays I created previously, A1, A2, A3, which is the 1, 2, 3 dimensional array. So with this, you can, for example, I want to get the 0th index of this, my first A1 array. I can just call A1.0. These are ways of manipulating using NumPy to give me this answer, which is 1. For A2, also the first one, which should also be 1. These are, you can call it slicing with NumPy. Functions in NumPy. So I'm not going to dwell more on that. To get the second row index 1 of the A2, I can just call 1. So if you remember in Python, indexing starts from 0, doesn't start from 1. So it starts from 0. So if I want to get the index 1 of this my A2, this is my A2 NumPy array. To get this index 1 here, I just call this A2 brackets 1 to give me this value here. So these are just basic using Python in NumPy. Also to get the first two values of the first two rows of both arrays. I can just call using this particular code to give you the answer. So if you don't understand slicing yet, you can do research on that. It's pretty straightforward and easy. Okay, creating another type of NumPy array. This is like a bigger type. So why I'm doing this is just for you to get a baseline understanding of how NumPy arrays work with, because when you get to work with data sets that's a data frame that's already set, you know how to go through them once you have an understanding of arrays, because these are just basically matrix and vectors array creating. This is a 2 by 3 by 4 by 5 array. When I say 2, this first set 1, 2 by 3, which is 1, 2, 3 by 4, which is this line. Remember from anatomy, by 4 by 5, which is this other index 2, 3, 8, 1, 3. So let's check the shape. You already see the shape is a 2 by 3 by 4 by 5 matrix. And doing aggregation with NumPy arrays, you can do your basic aggregation by summing, mean, max, mode, division, standard deviation, multiplication, and all that. So let's just get on with it. You can use np.sum to get the total values in your array. There's another one for finding the mean. You can use np.mean. These are already on the NumPy documentation. You can go back if you don't understand it. So these are basic steps before we get to the nitty-gritty. You can do to find the max value in your A2 array. You can use np.max. To get the minimum value, you can use np.min. To get the standard deviation of your array, you can use np.std to give you standard deviation. Okay. So to get the shape. And mind you, when you are doing aggregation in NumPy, sometimes you have to have the same shape. If not, it will give you, it might not work. So we'll see an example about that. So if you see this, when I added A2 plus A3, it didn't work. It's showing upper to number of cards together with shapes, different shapes, because it's a 2 by 3, and it's a 2 by 3 by 3 array. So after reshaping, we can now add what's the thing. So basically, we have to do a reshape so you can add both array. So there's something called reshape to change it to the array, because this was a 2 by 3 by 3 array, and this is a 2 by 3 array. So meaning we have 2-dimensional and 3-dimensional array. So there's something else called transpose. You can use it .t to transpose your array and also the shape to get it. So then there's a dot product when adding different arrays together using what we call the dot product. So basically, let's just create a random array. Everything I'll be doing, I'll be creating random arrays. Yeah, basically. So Moving on, you get to see how this works when you work with a data set. So let's see. Two. So checking the shape of both. So it's a 2x2 two-dimensional array. So I can add them by dot products. I use what we call np.dot. But if the shapes are still not aligned, you cannot do a dot product. So to do enable you to do a dot product, you have to do what we call transpose. So to do that, I have to transpose the first array I created. Mind you, I created them using random number. This code there, np the random around it, np the random around it. So if I transpose and check the shape now, then do np.dot same shape and I've transposed the other one. I don't have network. Okay, good. You see, it could work because I did a transpose of my second matrix. So these are basic statistics. So I'm just doing this so you have a clear understanding when we start working with standard data frame. So now I'm going to create a dummy data set called sales amount using the same random rand int to create it. And I call it sales amount. So this is it. Then I'm putting it in a data frame. There's something called data frame in Pandas. By doing that, I can use pd.data frame. So, and in data frame, just like a dictionary, I have key value pairs. There's a key and there's a value. Like here we have so with this, it's in a data frame already. So instead of it being in this matrix form, it's already in a data frame. So moving on, creating another column called prices. Then another one called butter prices, as the price is changing it into like data frame also. So this method I'm using dictionary method to create a data frame that's like a data set, basically. That's what I'm doing with this code. So putting everything together, calling it total sales. But doing this using the dot product, that's I want to add this data frame and this data frame. That's putting this into this data frame using the dot products. That's putting a new column. To do the dot products, it didn't work because they are not of the same shape. If you notice the error message saying the shape are not aligned. So to do that, I have to transpose this sales amount that this butter prices using the transpose method. After that, checking to see the shapes if they are the same. Now they're like the same. That's two-dimensional array. And also, I have to transpose this also. So that will be of the same. So I can add it using the dot product. So running this code, the shape, check the other shape. They're the same. And now checking the weekly sales data frame. This is it. So I want to add them together. If you notice that it has already worked based on use the butter price. I added this butter price into this weekly sales sheet. Previously, it wasn't there. So this is another way of manipulating your data to add it. So moving on, these are just preambles. By now, you probably might not understand them. Get it? So these are just preambles. I hope everyone can hear me clearly. If you can, just drop it in the chat. Okay, okay. Moving on to pandas. This is very wasted time. Okay, cool. All right, we just did some few manipulation with NumPy by using the dot products, creating arrays, aggregating it, and all that. So these are just the preambles of NumPy. That's what I'm showing you. So when we start working with the data sets, you get to understand it better. So then move on to pandas. Pandas has two main data types. We have the series and the data frame. Series is a one-dimensional column of data. Data frame, mostly column, most common is a two-dimensional table of data with rows and column. So you can create a series using pd.series and passing it to a Python list. You can create a data frame by using pd.dataframe and passing it to a Python dictionary. So the ways of importing your pandas is importing pandas as PD. I can import pandas as whatever, but this is the standard way .pd. I have a generic way of setting your code. So I'm going to create a dummy data set called cars using pd.series. If you have any questions after this session, definitely I would reply all questions. Let's just focus on now. Just drop it on the chat on YouTube and also on Zoom. I would reply them. So import pandas as PD, created a series pandas data called cars, BMW Toyota Honda, creating a series of colors. Now I'm just creating series of data. And after I'm done with this, I can put them in a data frame. So I created the cars, I created the colors of the cars. Now I want to create a data frame of cars and color. Like I said, if you understand dictionary in Python, different data types in Python, with the data frame works like dictionary when you have the key value pairs. So in this, I called the key car type and I'm calling the value cars, which is this series data, and the colors, I'm calling these colors, which is the series data, I'm putting it in the data frame. And when we're done, you see how the data frame looks like. Already have a data frame. So this is a pandas data frame. Previously, this is a pandas series. This is a data frame. Then now, done with creating dummy data set, I want to import a data set I already have before in my system. So called cars. So the way of reading a data set in pandas is pd.read_csv. If it's a CSV file, use pd.read_csv. If it's an Excel file, it's pd.read_xssl. If it's an HTML file, you can also read it using the link to the HTML file. So there are different ways of reading data sets. Pandas, can just check the documentation, you understand. Okay, this is like a pandas data frame of a data set. If you don't understand this here, I have a pictorial view for you to understand. So using this pictorial view, right? This is the column in the data frame, this column, and it's also called axis 1. So whenever you're doing a manipulation of the data, if you want to manipulate the column to represent it, you can call axis equals to 1. Then the rows are axis equals to 0. These are the rows. You can see my cursor. Then the index in Python always starts from 0, not 1, basically computer science. Then these are the data in the data frame. This, and also this is just like a pictorial view, excuse me, of the pandas data frame or like a data set. The column as this 1, the rows as this 0, then the index 0, 1, 2, 3, 4. So of this particular data frame. So moving on, let's check the data type. It has the make column is an object, the odometer is an integer. So by now you should know the different data types in Python: object, integer, floats, numerical, categorical data. So there's the code in pandas called describe to show you a short description of your data sets, the count, the mean, the standard deviation, 25th percentile, 75th percentile, and all that. So this is just like a short way of reviewing data. Checking, there's another code called .info to tell you give you an information about your data. Here we have 10 entries that our data has the 10 entries from 0 to 9 index, memory usage, the objects, and all to tell you how many categorical data, numerical data, and all that. So this is just like a wonderful way of representing it. And also there's also another code called .main if you want to check the main of your data sets. For this, .main will only work for numerical data, that is numbers. It will not work for objects, which is categorical data. Like this make column is an object. Why I said object is because it's called Toyota, BMW, Nissan, it's an object. Why is this a numerical data? So integers. Moving on. That's why if you notice the .main gave you the main of only the numerical columns. So there's another one to check the columns in your data frame. You can call the data.columns to give you all the columns in your data sets. So I want to save the cast column to a list. These are ways of wrangling data. And I want to call, since it's already in a list, remember we have a series data and a data frame. So doing this to call it out like in the form of a series, I've saved it in a series. I want to check the first column in my series, which is the make column here. These are ways of wrangling the data. To check the index, it starts at 0, stops at 10, meaning I have 10 columns in this data set. So this is just like a small data set. Moving on, you can also check the length of your data frame using the len code, len dot, then call the name of your data frame. So the length is 10, also like showing the index. So viewing and selecting data, first of all, these are ways of wrangling and manipulating your data set. Like remember, you can use pandas to wrangle and manipulate your data frame. So I want to check the first 5 rows of my cast data. This will check the first 5 rows using .head stance. It's like a default setting in pandas. .head will give you like a summarized version of the data frame. If you want to check the first 6 rows, you can call .head and put in 6. So if you have a large data frame, you can just use this to wrangle it. Then if you want to check the last 5 rows, you can use .tail to give you the last 5 rows. Then there's another function in pandas called the .lock and .ilock. .lock takes an integer as input. It chooses from your series or data frame whichever index matches the number. So I want to select row at index 3 in my cast data frame. I can do cast.location 3. So it will bring out everything in that index 3 that's in the row. So if you go back, it brought out BMW, black, the color, the odometer. Let's check it. If you notice, this is 0, 1, 2, 3. This is the third index, the location, to bring out everything in that particular row. That's a function of .lock. Then there's also another one called .ilock. It does a similar thing, but works with the exact positions. So those are the differences. You can also do slicing with .log and .ilog. So if I want to get all rows up to and including index 3, I can do dot location using this code, column 3. So it will bring out everything from the beginning to this third index 3 here. Or you can say index 4, since that's from 0, 1, 2, 3, that's the fourth row. And also ways by which you can use alloc or log when you're referring to indexes. When you use .alloc is when you're referring to positions in the data frame. That is when the index is out of order. And also, if you want to select a particular column, you can use the column name instead of using alloc. So for example, I want to select the color column in my data sets. I can use classes bracket column. So this is a simple way of wrangling the full data in that particular column called column. So, and also you can use Boolean method, Boolean, that is true or false. Oh, sorry, if this is equals to this or not. So that's Boolean, true or false. So it works with column selection. So we're using it to select the rows which fulfill the condition we passed in it. So I want to select cars with over 100,000 on the odometer. We check our data frame, the odometer column. It has 150,000, 87, 3,200. So I want to select only the data that has from 100,000 and above. So that's where this comes into play using the Boolean method. I can say, okay, where in my classes data frame, where we have the odometer, the value greater than 100, select only those data, and to give me these two in a data frame that has odometer of greater than 100,000. And if I can also select which of my data frame has the make called Toyota, data frame, and use this in my classes data frame in this make column, which of them is equals is the same as Toyota. These are ways of wrangling your data, manipulating your data. Another function you can use is called pd.crosstab. It's a great way to view two different columns together and compare them. So you can use pd.crosstab, call the, for example, I want to check this make column and also crosstab this doors column. I can use pd.crosstab. It will give me to compare the two different columns, doors and the make. Then if you want to compare more columns to the contents of another column, you can use dot group by. This is another way of wrangling your data. For example, I want to get this make column and I want to find the mean of, I want to group the make column and find the mean of the other columns. I can use dot group by, and voila, it will give me the mean of the make. I will get the make and the mean of the other columns. Mind you, my data frame have only the odometer and the doors are numerical data. So that's why I brought out the mean of each row for them. So going to manipulating your data, I want to lower the make column that instead of everything to be in capital letter, I can make it to be lowercase. There's something called .string.lower. It works with just strings too. So with this, my data frame, everything is in lowercase. I can make the make to be lower also using this code. In the mind you, this brought out a series data type. So this lets it to be change everything in my data frame to lowercase. That's the make, and in place I can also create a column called the classes make. I want to get this make column. I want to change everything in this my data frame of the make column to lowercase. This was what it did, and everything came out lowercase. Mind you, if I didn't run this code after doing just this first one, it won't work because this is like a series data. It's not in place. So with this, you call it this equals to this using this code. Another function to check if you have missing data in your data set or data frame is called .isnor or .isnar. So you can use .isnor.sum to give you if there's any missing data. In our data set, there's no missing data. So this is like ways of wrangling and manipulating your data set using. So this data frame does not have any missing data. I already have another data set that has a missing data. Let me just import that. So if we check, if you notice none, it's showing none represents missing. That's it wasn't recorded when they created this data set. So now checking if there's a missing data, you can use isna or isnor, it's the same thing. So in this my data set, there are missing data. In the make column, there's 1, in the odometer column, there's 4. So there are ways of handling missing data in your data set. Mind you, the columns that have missing data, it depends on the size of your data set. So sometimes you can just drop the missing data if the missing data are not much compared to the size of your data set. But if the missing data are much, you just there's a way of filling the missing data. So for this, my odometer column that has 4 missing data, I can fill it using the fill now method. It's a method in pandas. I can fill it using the mean value. Since my odometer is a numerical data type, I can fill it with the mean of the total data in my odometer column using this function. I'm calling the odometer column. I want to fill it using the mean value. Filling this, so to bring out a series. Mind you, there's just follow along, you see a difference of what I want to do. This will bring out a series data. If I check my data set again, you are still seeing that it didn't work. It's still showing missing value. This is because this value called in place is set to false, and this is set to false by default. So the way to make it that after I've done everything in that column that will be in place, I can say in place equals to true. So let's run it again. Change this in place equals to true. You notice it didn't bring out the series data based on the already run it in the data frame. And now if I check my data set, the mean values, that's the missing values, have been replaced by the mean value of the total number in this data frame, my odometer column. So checking for the missing data again, we still have, we've already filled the missing data for the odometer column. Now you can see it's showing 0. So to handle the missing data of these other columns, I can drop, since these are not significant compared to my data set, this is a small data set, and the missing data is just 1, 1, 2. I can just drop it. It's called drop now. Drop now in place true. It will drop every missing data in my data set. And voila, we don't have any missing data. So this is just like a introduction of how you handle missing data in your data sets. So sometimes instead of removing or filling data, what if you want to create a new column in your data sets? You can create new columns to structure data. So using pandas and NumPy tools. So let's just dive right into that code. So for example, I want to create a column called cars data sets. I'll create numbers. Mind you, this is because it's small data. So I can just create this column with random numbers and call it car says ng size column. It's equal to ng sizes, which is my series data. Then run it. You see, I already have a column added to my data set. Then I can also create a new column, setting up values to a one standard value. For example, since I created this ng size column by creating a series of different numbers, I can just let everything be 4, just 4, and to run through the 10 rows. So let's call number of weeks, creating a column called number of weeks, since this is a data class data. So the number of weeks was added to my data frame. So all of them 4 weeks, 4 weeks, 4 weeks, 4 weeks. Also, I can remove a column using the drop method. Drop, then the column name, and as this one. If you remember from the anatomy of pandas data frame, as this one is the column, as x0 is the row. So to do this, since the engine size is a column, I want to drop this engine size. I can say drop classes.drop engine size as this one. So this code will tell this as this one will tell my code that I want to drop the engine size column, the full column. And voila, once you do that, it's in place, and the engine size column has been dropped. So basically, these are just the simple introduction on NumPy and parties, how we wrangle it. So how you wrangle the data. So basically, yeah, sorry about that. Basically, this is just like the introduction to wrangling of the data using your NumPy and your pandas. So now I'll answer questions. So moving on to the questions, in the chat, I say, will this code will later be shared? Yes, it will be shared in the Slack channel. The link to the notebook and also the CSV file, it will be shared. Any other question? Just drop it in the chat. Okay, there's a question about the shape. So I should explain the shape of the NumPy array. So with this pictorial view, you should get an understanding of the NumPy array. This is just like a shape. This is a 1x3 dimension. If you understand matrices and vectors, it should be simple for you to understand. So this is just like a pictorial view of a NumPy array. A 1x3, a 2x3, array and a 2 by 3 by 3. If you can see my cursor, a 2 by 3 by 3 in this picture. This is 2 representing the green, and this is 3 representing the axis 1 and the axis 2. So this is just like a simple anatomy of a NumPy array. So any other question? Then how two shapes can combine? I didn't get that part. 2 by 3 and 2 by 3 by 5. If you're listening attentively, I said if you want to combine that, you have to transpose, do a transpose. So let's go back to this part. You see the error when I did it. So A2 and A3 are of different shapes. If you see it, throw an arrow. To do that, I had to reshape my A2, which is a 2 by 3 to a, which is a 2-dimensional. This is a 3-dimensional. So I reshaped it to a 3-dimensional array. And after that, you cannot add it. So you have to reshape. If you are doing a dot product, you have to do dot transpose. So that's just how you can do that. Any other question? Okay, any other question? Let's go back to YouTube. Let's see if there's questions on YouTube. Okay, so from your code, can we use dot product to add to database? Yes, you can, depending on the shape of your data, depending on the All right, there's another question on YouTube saying, how can you read your data set you already have on your laptop? You can use that using the pd.read method. If your data set is a CSV file, you can do that calling the name of the file and the location. If you are using a Jupyter Notebook or a Colab, if it's a Colab, you have to go to the location of the data sets. So it's pretty simple. If you still don't understand, just go online, you see it's straightforward, and also it's also on the material too. So any other question before we round off this session? Any other question? Okay. We have time for 2 more questions. If there's none, we can just call it a day. Okay, there's none yet. Okay, for this stage A, if you've noticed, you've gone through the courses, attempts. If you are done, you're satisfied, attempt the quiz, and after attempting the quiz, you know there's a tag along project alongside. Okay, I say there's another question. Let me just go back to that question. Okay, the question says if you can get this data set. Like I said, it will be shared in the Slack channel. This data and the notebook to be shared. You see it in the announcement channel. Okay, like I said, there's a tag along project alongside this stage A course. You have to complete it, complete the quiz, and also do the tag along projects to have complete grades. So okay, I see there's no other question. Thank you all for joining this session. I hope you got a good understanding of the concept and all. And if you still don't understand, you can do your further research, check the code, check on Google, check the platform, and also ask the questions on the Slack channel to be replied. So thank you very much for joining me in this session. Until next time, have a lovely day.